Good morning all of you. In this chapter we want to discuss two more questions. Okay. Last question is question number 8. All of you take your textbook and page number 108, 108, question number 8. Okay. Read that question. A gardener has 1,000 plants. Okay. He wants to plant these in such a way that the number of rows and the number of columns remains the same. Okay. Find the minimum number of plants he needs more for this. Actually, now he had how many plants? 1,000 plants only. Okay. And he want to arrange these plants in a manner like that the number of rows should be equal to the number of columns. So, if he arrange in that type, then how many more plants he need to make this arrangement? So first we want to find out, is it possible to arrange 1,000 plants in same number of rows and columns? Is it possible? If it is a perfect square number only, then only it is possible to arrange in a square type. That is, number of rows should be equal to number of rows. So for that we are finding the square root of the given number 1,000. So the least perfect square just below 10 is 9. Its square root is 3. Then that will be the quotient also. 3 into 3, 9. Then subtracting we will get 1. Then bring down the next two places. Next, square of double of 3 is 6. Which number will be here only? 1 is possible. So same number here, 61. We will get 39. For 39. Okay. Now the question is it possible to arrange these 1,000 plants in the same number of rows and columns? It is not possible. How many plants remains without these? 39 plants remains. Okay. So the question is how many more plants he need to make such an arrangement. So how we can find out that? So next we are finding what will be the next. Here we got the quotient 31. Next we are finding the next number square. After 31 next number is 32. Then 32 square we are finding. What will be 32 square? 1024. Then how many more plants he need to make this arrangement? For that we are subtracting 1024 minus this 1,000. Okay. So the answer we will get 24. How many? Then he can arrange that in such a way that the number of rows will be equal to number of columns. Okay. So the answer is 24. Just like one more question is there. There are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to the number of columns. How many children would be left out in this arrangement? Okay, here total how many students? 500 students. So, same manner, if the number of rows and number of columns, if it is equal, then some students will be out of that. So, for that first we are finding the square root of 500. We know it is in long division method we can find otherwise we know which is the least number just below this 500. Otherwise that type also we can find out. So here it will be 2. So 5 minus 4, 1. Then bring down the next. Then double of 2, 4. Which number will be the to multiply to get the same number? 42. Okay. So 42 into 2 it will be 84. 60. So the question is how many students would be left out in this arrangement? If they arrange like a man, that number of rows should be equal to number of columns. How many rows and how many columns will be there? 22 rows and 22 columns will be there. But after that arrangement, how many students will be left? 16 students will be left. Okay, that type we can answer. So this chapter finished. So next day we already informed that about the test paper of this chapter. For that, all of you study very well. It is very important chapter. Okay, find squares and square root. For that, which is the important matter we discuss in this chapter? All of you know what's the square? How to find out the squares of numbers, and some properties of squares also we discuss. First is how we find out the number of numbers between two consecutive square numbers. Okay, between two consecutive square numbers, how we can find out the numbers. Suppose n square, we find out if it is how many non-square numbers will be in between n square and n plus 1 whole square. How we get this? That's a general method we find out. There will be in between n square and n plus 1 whole square, there will be 2n non-perfect square numbers. That is, for example, if it is between 13 square and next after 13 it will be 14. In between 30 square and 40 square, how many non-square numbers will be there? It will be 2 into n. Instead of n, it is 30. So 2 into 13, 26. That is an important property. Another property what we discussed, the sum of first n odd numbers is equal to n square. 1 plus 3 plus 5 plus etc. plus n. What is its answer? It will be n square. If you add how many odd numbers, that will be its square. Suppose 1 plus 3 plus 5 plus 7. Its answer will be, how many we add? 1, 2, 3, 4. Okay, 4 odd numbers we add. So it will be 16, like that. Next, we add another property we discuss. How we find out the square of, now squares of odd numbers can express as the sum of two consecutive natural numbers. Squares of odd numbers we can express as the sum of two consecutive natural numbers. How we can do that? Suppose one number, if it is, how we n is an odd number, then n square we can express as n square minus 1 by 2 plus n square plus 1 by 2. That two numbers we can find out by, with the given number, its square, we subtract 1 then divide by 2. Another number will be add 1 then divide by 2. The sum of that two numbers, we can express that n square using that 2. Suppose one example you look, 11 square. 11 square, how we can express as the sum of two consecutive numbers. So this we can do as 11 square minus 1 by 2 plus 11 square plus 1 by 2. Okay. 121. 11 square we know 121. 121 minus 1, 120. 120 by 2, 60. Plus, here it will be 121 plus 1, 122. 122 by 2, it will be 61. So 11 square we can express as the sum of 60 and 61. They are consecutive numbers. That type of question also very important. One is a very important property of square numbers. Next property, Pythagorean triplet. That is very important. Okay, if for any natural number m greater than 1, then 2m whole square plus m square minus 1 whole square will be equal to m square plus 1 whole square. Okay, this 2m, m square minus 1, m square plus 1. These three numbers are called Pythagorean triplet. So, if we give one member of that Pythagorean triplet, we can find out the other two members using this equation. That's also very important. Next, we find out how we can find out the square root. What is square root? Inverse operation of squaring is called square root. And what are the different methods for finding square root? First, we discussed repeated subtraction method. Next one is prime factorization method. Then third one is long division method. After that we discuss how we find out the square root of decimal numbers. Okay, then using this concept how we can do some word problems. Very important, all of you study well, and also I already give that exam portion, first term exam lessons also I already sent you. So today onwards all of you start studying. One more thing, all of you study only by doing. In the case of maths, only study by doing, not by reading. Okay, thank you.